Today we're going to cover 8.5 different properties. And before we move on to the properties, let's review 8.4. And I'm going to take this and I'm going to rewrite it as an exponential form from logarithmic. So we take our base, and we want to find out what that's going to be without using our calculator. We take our base of 3, raise it to what power, gives us 9, and then we can see that when we square 3, so our x is going to be equal to 2. That's one way. We also can rewrite this. If I had the log base 3, I can rewrite 9 as 3 squared. And then we talked about in 8.4 that log base 3 of 3 cancels out and we're left with just 2. Same for our next one. We have 4 times 16, but 4 can really be 2 squared. 16 can really be 2 to the 4th power. And from last chapter, if I've got bases that are being multiplied together, I'm just going to add their exponents. My base is going to stay as 2, and that's going to be to the 6th power. So the 2's cancel, and we're left with just 6. And last, we've got log base 2 of 4 to the 4th power. I'm going to rewrite 4 as 2 squared. But 4 is being raised to the 4th power, so now 2 squared is being raised to the 4th power. A power to a power means we're going to multiply. So now I've got 2 to the 8th power. That cancels, and we're left with our answer is 8. Alright, so moving on to 8.5, there are 3 properties that are associated with logarithms. If I've got log base b of u times v, what I'm going to do is I'm going to separate this. I'm going to break it into 2 pieces. If I'm multiplying, that means I can break it into 2 pieces where I'm adding. Okay, so log base b of u times v, if I expand that and break it apart, it comes from log base b times u plus. So multiplication gets transformed into addition. So if I've got division, when I break that apart, it's going to be separated by subtraction. And our last property, if I have an exponent, so if I've got log base b of u to the v power, when you rewrite this, you put the exponent out front, so it's v times log base b of u. So those are the 3 properties that we're going to use today to expand. So we're going to take one piece and we're going to expand it into all of its pieces. So I've got log base 2 of 3x. So the first property I was multiplying, and to separate it I use addition. So this is going to be log base 2 of 3. I've got 2 pieces in here, so I'm going to have 2 pieces in my answer. Log base 2 of x. When I look at number 2, I've got log base 3 of x squared. I look at my 3 properties. I have my last property here where I'm raising something to an exponent. I bring that exponent out front so it becomes 2 times log base 3 of x. Number 3, when I look at my number here, I'm dividing 2 divided by x. So I've got log base 3. When I look at my rules, if I'm dividing, that means I subtract. So I have 2 minus log base 3 of x. Next one. Now for number 4, I've got log base 3 of 4. There's no multiplication, there's no division, and there's no exponents. So it looks like there's nothing I can do, but you've always got to look to see if you can break things down, just like in the last chapter. I can take 4 and I can rewrite 4 as 2 squared. Once I rewrite it, now I can use that third rule, move the exponent out front, so it's 2 times log base 3 of 2. We look at number 5. I've got 9 times x to the 3rd power. So since I'm multiplying 2 pieces, I'm going to have 2 pieces in my answer, log base 5 of 9. Multiplication translates into addition, and log base 5 of x to the third. Now, once you separate your two pieces, look at the 2 and make sure that you can't break it down further. I look at my first one. 9 can be broken down as 3 squared. When I look at my second piece, I can't break down x, but I can simplify by putting the 3 out front. Then I double check, and I can do the same thing with my first piece now. I've got 3 squared, so I can bring the 2 out front. 2 times log base 5 of 3 plus 3 times log base 5 of x. And we double check, there's nothing else that I can break down, nothing else that I can break down. Looking at number 6, we've got 4 divided by 5, and our rule says that if we divide, we separate it by subtraction. So I've got log base 4 of 4 minus log base 4 of 5. There's a couple different things you could see here. 1, 4 becomes 2 squared, but you also should see, remember that log base 4 of 4 cancels, and you're left with just the exponent. And that's really 4 to the first power. So this breaks down as 1 minus log base 4 of 5. Alright, next page. They're going to get a little bit more complicated. We've got log base 3 of 9 times x to the 4th power. So since I'm multiplying the two pieces, that means I separate them by the addition sign. I look at my first piece. I can break down 9 as 3 squared. And the second piece, I can bring my exponent up front. Alright, we go back to our first piece. I see log base 3 of 3 cancel, so I'm left with 2 plus nothing can be broken down there. So there's my answer. Number 8, it's not a log but a log base 3 or a log base 5, but it's the natural log. So you're going to treat it with those same rules, those same 3 rules that we used for all the last couple problems we're going to use here as well. So now I've got 3 pieces. I've got a 5, x squared, and y to the 5th. Since I have 3 pieces here, I'm going to have 3 pieces in my answer. Since it's all multiplication, they're all going to be separated by addition signs. So natural log of 5 plus natural log of x squared plus natural log of y to the 5th. Notice that our base that we use here is going to be the same base that it's used in every single problem. I've got log base 3 with my first piece, log base 3 with my second piece. So I have natural log here, I have natural log in all 3 pieces. Whatever that log is going to be the same log for all of your pieces. Alright, so let's go continue expanding this. Natural log of 5. Can't do anything there. Natural log of x squared. I've got an exponent, so I bring that 2 out front. And then our last piece, we've got an exponent of 5. We bring our 5 out front. And now we've completely expanded that piece. And number 9. Once again, we have 1, 2, 3 pieces that are being multiplied together. So I've got the natural log of 4/3 plus the natural log of x squared plus the natural log of y. Then I look at my first piece. Within that first piece, I now have division, 4 divided by 3. So now I separate that 4 and the 3 with subtraction. So natural log of 4 minus the natural log of 3. I look at my next piece. I've got an exponent, so that exponent goes out front. 2 times the natural log of x. The third piece is already expanded as far as possible. Alright, I look at my first piece. I can rewrite 4 as 2 squared. Can't rewrite 3. Can't rewrite the x. Can't rewrite the y. So then I just bring that exponent out front. And our final answer is 2 times the natural log of 2 minus the natural log of 3 plus 2 times the natural log of x plus the natural log of y. So the trick to when you're expanding, you want to take it one step at a time. So I see that I've got 3 pieces that are being multiplied. That means that they get separated with addition signs. Then you look inside each individual term and see if there's something else you can break down using those 3 rules that we talked about in the very beginning. Alright, we've got one question left, and I want you to hit pause on this and try this one on your own and see if you can figure it out. Alright, let's see how you did. First thing I did is I looked at the square root of 16x and I simplified that. I know that the square root of 16 is 4, so 4 goes to the outside, and I can't break down the square root of x any further. So this becomes log base 4 of 4 times the square root of x. I'm multiplying here, so I'm going to break it into 2 pieces, 4 plus, since multiplication gets separated with an addition sign. Then I look at the first piece, log base 4 of 4. That's our piece where it cancels out, and you're left with your exponent of 1. And log base 4 of the square root of x. I change it from the square root. We know that the square root is the same thing as x to the 1/2 power. So I change it from a radical to an exponential to an exponent to a fractional exponent, and that allows me to bring my exponent out front. So I've got 1 plus 1/2 of log base 4 times x. And that's it for today.